In this lesson, we will be finishing off the section on solving inequalities. So, to solve a polynomial inequality, here's the following steps that we need to do. What we do is, first off, we get a 0 on one side. The goal is if we can get it equal to 0 as an equation, we can use those to help us solve the inequality. So then, we solve the corresponding equation, so we get it equal to 0 and change the inequality symbol to an equal sign. And we solve the equation in whatever manner we need. Then what we do is we place these solutions on a number line, and we'll put test values in each of these little intervals that we're going to create. What we'll do is we'll check the test values in the original inequality. So then finally, if we get a true statement, this means that that whole interval is going to be part of our solution set, whereas if we get a false statement, that means that we're not going to be using that at all. And in general, we need to check our endpoints. However, for polynomials, I will mention a little bit less that you need to do. So let's start off with this example. You'll notice that this inequality is already having a 0 on one side. And so what we're going to do is we're going to solve the equation x squared plus 2x minus 3 is equal to 0. So we can solve this by factoring. This is x plus 3 times x minus 1, that is equal to 0. And so we say, well, that's x plus 3 equals 0, or x minus 1 equals 0. So x equals negative 3 is one solution, and x equals 1 is the other solution. So that was the first two steps. So what we're going to do is we're going to make a number line. And on this number line, we're going to put the numbers negative 3 and positive 1. And then what we need to do is choose test values. So by putting two numbers on the number line, I have split it into three distinct intervals. So I'm going to pick a number to test from within each of these intervals. And you do need to make sure that the number that you pick is not one of these endpoints. So I'm going to choose negative 4. And then I'm going to choose 0 for this interval. If 0 is an option, it's always a good choice. And I'm going to choose 2 for the other one. So, what we can do with this now is we're going to take these numbers and we're going to plug them into the original inequality. So negative 4 squared plus 2 times negative 4 minus 3. We want to know if that is less than or equal to 0. Alright, so we get 16 minus 8 minus 3, and that is equal to 5. Less than or equal to 0? No. So I'm going to put false along this way. And then let's do 0 next. So 0 squared plus 2 times 0 minus 3. We want to know if that is less than or equal to 0. Well, I think it's pretty clear this is negative 3. Is that less than or equal to 0? Yes. So true this way. And then finally, let's check 2. 2 squared plus 2 times 2 minus 3. Is that less than or equal to 0? Well, we get 4 plus 4 minus 3 is 5, and that is not less than or equal to 0. So this one is false also. So we just need to write our answer based on the places that are true. So the fact is that the only place where these can switch for polynomials is where they were actually equal to 0. So if it's true for one value on the interval, it's true for all the values in the interval. So the numbers between negative 3 and 1 are going to all solve this inequality. Now the final question is, what about the endpoints? All you have to do is look at this symbol. Since this symbol is a less than or equal to, the endpoints were equal to 0, and that means they satisfy the inequality. So I'm going to say negative 3 to 1 with brackets is my solution set. Next example. 2x squared greater than x plus 6. Now for this one, the first thing I'm going to do is subtract the x to the other side and subtract the 6 to the other side, and now I have this as greater than 0. Now I believe this one can be factored, and just to save us some time, I'll go ahead and factor it for us. So this one is looking to me like it's going to be a 2 here, a 3 here, and how about a minus and a plus? Does that work? 2x squared minus 4x plus 3x is my minus x, minus 6. Okay, great. And I want to set this equal to 0 because, again, I'm trying to solve the corresponding equation. So here I get 2x plus 3 equal to 0, or x minus 2 equal to 0. So I get 2x equals negative 3 and x equals negative 3 halves as one solution, and x equals 2 is my other solution. So again, you solve the resulting equation, not paying attention to the fact that it's an inequality. Then we plug these numbers in on a number line. And I am keeping them in order deliberately. So let's pick some test points. To the left of negative 3 halves, I will pick negative 2. Between negative 3 halves and 2, I will pick 0. And larger than 2, I will pick 3. And then what we do is we plug these back into the original inequality, although you could use this inequality if you wanted to. But plug them back into an inequality and just see if they are true or false. So, 2 times negative 2 squared, we want to know if that's greater than negative 2 plus 6. So this number is 4, and 4 times 2 is 8. Is 8 greater than negative 2 plus 6 is 4? Yes. So true for this one. Alright, let's try 0. 2 times 0 squared. Is that greater than 0 plus 6? On the left I get 0. On the right I get 6, and 0 is definitely not greater than 6. So this is false on this interval. And then finally 3. 2 times 3 squared greater than 3 plus 6. Well, 3 squared is 9, and 9 times 2 is 18. Is that greater than 3 plus 6, which is 9? Yes. So this one is true. So now we just need to determine, what about the endpoints? Well, this time it's a strictly greater than symbol, which means I cannot include my endpoints. However, this interval to the left works, so that's negative infinity to negative 3 halves, union, and then the interval to the right of 2 also works, so I get 2 to infinity. And again, I use all parentheses because this problem was a strictly greater than problem.